Here's, check it out, example 3A, which is another one for your notes page. Notice that f of x equals 4 and f of x equals negative 2. That should indicate to you that this is a step function. Okay? That means that the lines will be flat, not curved, they're not parabolas, they're not y equals mx plus b. It's just 4 and negative 2. So if you look at the first one, x is less than or equal to negative 1 when f of x is 4. So you're going to go to negative 1, comma 4, and since it's equal to, you'll put a filled-in circle. Less than means the ray will go to the left. Then you have f of x equals negative 2. So you go to negative 1, comma, negative 2. You put an open circle, and since x is greater than, then the ray will go to the right. Take a look at the drawing here. A closed-in circle at negative 1, comma 4, ray going to the left. An open circle at negative 1, comma negative 2, with a ray going to the right. Here's check it out 3B. You're certainly invited to write this down. You can flip your notes page over. Look at the top one, negative 3x. This is y equals negative 3x. The intercept is 0, so you start at 0, and then your slope is negative 3 over 1. So you go down 3 over 1, and you would draw a slanted line. Keep in mind that you're only going to show the part of the graph where x is less than 2. The second one is x plus 3. The intercept is 3. The slope is 1. So you would start at 3. Then you would go up 1 over 1 and draw your second point. Use a ruler to draw your line. And you would only show the part of the line where x is greater than or equal to 2. Keep in mind here again as you draw, the first function has an open circle shading left for less than. The second one, the lower one, is going to have a closed circle with the arrow or the ray going to the right to indicate greater than and equal to. Take a look at this graph and make sure it is exactly what you drew on yours. If not, compare, go back, and figure out what went wrong. Remember, piecewise functions are not necessarily continuous. A step function has these breaks in it that looks like it steps up. It might appear to have gaps. To write the rule for a piecewise function, determine where the domain is divided into segments and write a separate rule for each segment or each piece. I want you to pause this video now, and I want you to watch Berger show you example 4, and then I will also go over that with you. You should have watched Berger doing the sports application. The last slide reminded you of the distance formula. Let's look at this example, and I want you to try this on your own before you let the video continue. So once we've read this, you should make a table showing the time, distance, and rate for swimming, biking, and running. Alright, let's read over this together, and you fill in your table as we go. Jennifer is completing a 15.5-mile triathlon. She swims a half a mile in 30 minutes. She bicycles 12 miles in 1 hour. There's your rate, 12 miles per hour. And runs 3 miles in 30 minutes. Take a minute and figure out your rate. Rate is the distance divided by time. And put all of your numbers in your table. Pause it now because the next video will show you how everything looks in your table. Hopefully you got it just like this. Swimming, biking, and running. A half hour, a half mile is 1 mile per hour. Half, 0.5 divided by 0.5. Biking, 1 divided by 12 is 12. 12 divided by 1 is 12. Running, 3 divided by 0.5 is 6. Notice the mile per hour means mile divided by hour in order to get your rate. The next thing you're going to do on your own is to write your intervals. Here's where it gets a little trickier. I want you to notice that since this is all time related, it's all going forward kind of in a motion, you're going to start at 0 because you're starting at 0 time. So between 0 and 0.5 hours falls the first interval. 0 is less than or equal to t is less than or equal to 0.5. The second interval is biking. 0.5 is less than t is less than or equal to 1.5. Then she runs. 1.5 is less than t is less than or equal to 2. The next thing you need to do is make the coordinates of the places where her pace changes. In order to do that, you look back at the table and you know she starts at 0, so that's your first coordinate, and she ends at 0.5, 0.5. Notice that time is your x-axis and distance is your y-axis, so swimming ends at 0.5, 0.5. Biking will end at 1.5, 12.5, because you have to add the swimming and biking together. Running will end at 2, 15.5. If you need equations for those 3 intervals, you'll use those coordinates and the slope, which is rate, and the slope-intercept form in order to write your equations. Stop for a minute and make sure you can do that. To write the equations, you'll need to use slope-intercept form and the points and the slope. Plug in the points and the slope, solve for b, and then write the equation. The first one would be 0.5, 0.5 with a slope of 1, which is 0.5 equals 0.5 plus b. Subtract 0.5 and you get b equals 0. Your second equation, the point is 1.5, 12.5, and the slope is 12. The equation would be 12.5 equals 1.5 times 12 plus b. Multiply the 1.5 times 12, you get 18. Subtract that from both sides, and b is negative 5.5. So your equation would be 12x minus 5.5. I'm going to let you do the third one on your own. Here are all 3 equations because I am out of time and out of energy. Good luck with this. Watch the videos carefully. Write things down. Make sure that you are paying close attention all the way through this chapter so you can do well on the test.